For 2,000 years, the ruins of ancient Rome have been guarding a secret to a building material so strong, so incredibly resilient that it still has modern science scratching its head. So today, we're not just taking a trip back in time, we are cracking a recipe that could seriously change our future. And just look at this comparison. I mean, it tells you everything you need to know, right? 2,000 years versus what? Maybe 100 if we're lucky? This isn't just about old versus new. Roman concrete was built to last, forever. A lot of modern concrete, well, it almost feels like it's designed with an expiration date. That's not just a quality gap, that's a chasm. It makes you wonder, what did they know that we've forgotten? I mean, just think about the sheer audacity of it all. You've got the Pantheon's dome in Rome, still the biggest unreinforced concrete dome on the planet, with not a single steel rod inside. You've got aqueducts that march across entire countries, harbors that have been taking a beating from the sea for centuries. These aren't just ruins, they're proof of a material that just refuses to quit. And for centuries, that's all it was, a mystery, a puzzle baked right into the stones of an empire. This is Rome's enduring enigma. So what was it? What was their unbreakable secret? For generations of scientists and engineers, this question has been like the holy grail. And to find the answer, they had to stop thinking like builders and start thinking like detectives. So this isn't just about admiring the past from a distance. Recently, a team of scientists decided to do something pretty radical. They were going to reverse engineer this 2,000-year-old technology. They wanted to figure out the entire process, to basically peer over the shoulders of Roman engineers from millennia ago. And this is where it gets really, really cool. They treated it like a forensic investigation. Think CSI Ancient Rome. The concrete itself was the crime scene, and the clues were these microscopic minerals and chemical fingerprints left behind when it was first made. Their whole approach was super methodical. First, they went back to the source, digging through ancient texts from guys like the architect Vitruvius. Then, they brought the ancient world into the 21st century, analyzing actual samples with some seriously high-tech scanning. And finally, and this is amazing, they used AI to visualize the entire mixing process, letting them test out theories in a virtual lab. And all that detective work, it paid off. Big time. They found the missing piece to the puzzle, a detail that was hiding in plain sight for centuries, something that completely changes how we understand this stuff. Now, it wasn't some kind of magical, secret ingredient you might be imagining. The main components, volcanic ash, lime, water, everybody knew about those. The real secret wasn't what they used, it was all about how they put it all together. The magic was in the temperature. Okay, check this out. It turns out the Romans used a process called hot mixing. Instead of regular lime, they used a much more reactive form called quicklime. When they added it to the mix, it created this intense heat. This process formed these little white mineral chunks you see here, called lime clasts. For years, scientists just thought this was a sign of sloppy work, but they were so wrong. These clasts were the secret weapon. Whenever a tiny crack formed and water seeped in, it would react with these lime clasts and form new crystals that filled the crack. The concrete was literally healing itself from the inside out. I mean, this just changes everything. The Romans didn't just make a strong material, they made a smart one. It wasn't just sitting there. It was designed to react to damage and actually get stronger over time. The longer it stood, the more it healed. It's an absolutely brilliant piece of chemistry. But you know, a theory, no matter how great it sounds, is just a theory until you can prove it. So the next step was obvious. Could they actually recreate this self-healing concrete in a modern lab? And that's exactly what they did. Using their historical research and those AI models, they weren't just making a block of concrete. They were resurrecting a lost art form. They were putting a 2,000-year-old theory to the test. The process they recreated is both simple and genius. You take the right kind of volcanic ash and quicklime. You mix them with water, and the chemical reaction itself generates all that heat, creating those crucial lime clasts. So in their experiment, they made 2 samples, one using the Roman hot mix recipe and one with a modern recipe. Then they cracked them both on purpose. And get this, the modern block just stayed broken, but the Roman block? Water flowed into the cracks, and within 2 weeks, it had completely healed itself. It worked exactly like they thought it would. So this discovery isn't just about solving a really old mystery. It's about taking a lesson from the past to, well, build a much better future. And this is where the story gets really exciting. Just look around us. Our infrastructure is literally crumbling. Our roads, our bridges, our buildings, they're all in this constant state of decay, needing repairs that are expensive and terrible for the environment. What if we could just break that cycle? What if we could build things that were meant to last for centuries, not just a few decades? The possibilities here are almost science fiction. Imagine roads that heal their own potholes after a bad winter. Seawalls that actually get stronger from the salt water that's trying to destroy them. And this isn't just about things lasting longer, it's about being more sustainable. This Roman-style concrete could have a way smaller carbon footprint, and the money we'd save on maintenance long-term would be astronomical. This quote from one of the scientists who worked on this pretty much says it all, doesn't it? We could be on the verge of a new age of building, one where we stop thinking short-term and start building for the ages, just like the Romans did. So I'll leave you with this thought. It's just an incredible story of rediscovery, and it's a reminder that sometimes the most revolutionary ideas aren't new at all. The key to building a more durable, more sustainable future might have been buried in the past this whole time, just waiting for us to finally crack the code.